Hi there, thanks for tuning in to today's video. In this video, I would like to show you how to implement one of the outputs of full adder, which is Cout, into three pieces of 2 to 1 multiplexers. First, let's make the truth table of full adder, but in this table, we only need to write the Cout as the output. This 0, 0, 0 will be 0, 0, 0, 0, 1 will be 0, 0, 1, 0 will be 0, 0, 1, 1 will be 1, 1, 0, 0 will be 0, 0, 1, 0 will be 1, 1, 1, 0 will be 1, 1, 1, 1 will be 1. And then let's split this table into two parts. We'll split here. And as we can see here, in these four rows, there is a pattern where when the A is 0, the Cout will be will have the equation of B and Cin. So this will be B and Cin. And for this part, this will be B or Cin. Let's consider that A is W3, B is W2, and Cin is W1. And from this equation, let's put the W3 as the focus point. So this will be W3, and the output will be Cout is equal to Y. So when the W3 is 0, Y will be B and Cin. And when the W3 is 1, the Y will be B or Cin. And then we put this equation into one multiplexer first. So this will be like this. This will be the first input, and this will be the second input. And then the first input will be B and Cin, and then the second input will be B or Cin, and the output will be Cout. So the selector, as we said earlier, we will use the A or W3 as the focus point. So this will be A or W3. And then we separate these inputs into another multiplexer, since we are going to use 3 multiplexer here. So this will be like this. First, let's make the first max we made earlier. This will be y, and this will be w3. And for the first input here, we are going to use the b and seen earlier. So this will be like this. And for the second input, we will use the b or cin. So we put the selector here, just like this. And from this table, let's use the b as the selector. So as we know that we change the b into w2, and then from here we know that this multiplexer is an implementation of AND gate, and this will be OR gate. That means when one of the input here is 1, the output will be 1. So we just need one input here, and the other input will be ground, or will be 0. And for the OR multiplexer here, we know that if one of the input is 1, the output will be 1. So in this input we use the VDD. That means it's equal to 1. And then in this input, since we use the W2 as the selector and the W3 as the last selector, we are going to use the W1 here. So it's going to be like this. Okay, this is how we implement the Cout of the full adder into 3 multiplexer. So let's check it if it's true or not. So when the W1 is 0, that means C is 0. And then W2 is 0, which is B is 0. This is 0, 0. This max will choose this input as the first input here. This will be like this, and then it will be 0. And in this max, it will choose the first input as low, this 0, and this will be 0. That means this input will be 0, since W2 is 0 here. And then so the result in this Y is, and if W3 is 0, it will choose this input as the output here. This will be 0 as well. So what if the B is 1, W2 is 1, but this is 0? So that means it will choose this as the input, but this is 0, the output will be 0. But in this max, it will choose this input as the output. This input is 1, so the output is 1, but the W3 is 0. That means it will choose this input as the output. The output will be 0. But if W3 is 1, it will choose this input, then the output will be 1. So that means if W2 is 1, that means B is 1, and then W3 is 1 as well. It will the output will be 1, just like this. And what if the W1 is 1? That means Cn is 1. That means it's like this. Since the W2 is 1, it will choose this input as the output. So the output of this multiplexer will be 1. And then if the W3 is 0, that means this multiplexer will choose this input as the output. So since it's 1, this will be 1, and then the output will be 1 as well. Okay, that's how we implement the cout of the full adder using 3 multiplexers. I think that's all from me. Thank you for watching.